So today on the list of stuff we've got to do, we've got a warm-up to handle. After that, we're going to go over the warm-up we had yesterday, which was about group work. So we'll handle those two warm-ups, and then we're going to get into today energy, the first start, or the first bit of this unit that we're going to do. When we talk about energy today, we're going to talk about potential energy. My first question before we do this is, when you guys did this before, did you learn potential energy well enough that you can tell me what it is right now? Yeah. Okay, that's all I was checking with, no problem. So the warm-up for today then was this. It says use your table group, so that means you were talking about stuff in your table group, to explain like the roller coaster thing. I assume you guys have all been on a roller coaster at this, or at least seen a roller coaster at some point in your life, even if you haven't been on one. Personally, I'm terrified of them. I do not enjoy roller coasters. That does not seem fun to me. Yeah, that... Nope. I just don't like roller coasters. Anyway, if you notice those things, once you're at the top of the first hill on a roller coaster, everything after that is like free energy in a way. Like they don't have to like hook you up and like pull you back up stuff. Everything after the first hill is free. The first hill, you got to get drug up there, up that big, long, steep hill. So the question is, or the explanation is, once you're at the top of that first hill on a roller coaster, how come you don't need any more like extra energy to make it out to the end of the track? How come you can just like be free from that and it all just happens? Yeah. Okay, that's part of it. You got part of it. What are some other explanations for that? How come it doesn't take more energy once you're like going? Chloe? Say it one more time. Kinda. Yeah, that's part of it. Spencer? Okay. Any of you guys skate on like a half pipe or anything like that? Okay, let me rephrase that. Do any of you guys know what a half pipe is? Yes. Okay. So a half pipe is just like, it's half of a circle, right? And that's what they skate on, and they can do tricks out of there and stuff. If you've ever skated on one of those before, right, there's a ledge. You put your back wheels against the ledge. You step on the tail of your board, and when you're ready to go down, you just transfer your weight to your front leg. If you don't do anything, what happens in that half pipe eventually? You come to a stop eventually, right? It's not like you just go on into infinity. How come you don't like just keep going up and down into infinity? Spencer? Right, because there's friction there. But you can make yourself go like higher each time you go. What do you got to do in order to get yourself like higher each time? Spencer? Yeah, you kind of like pump your legs as you go down and put extra energy into it. So what's happening here is, well, let me ask this a different way. Have you noticed which hill on a roller coaster is the tallest hill? Yeah, do you think that's by design or just by chance? Yeah, why might they design the first hill to be the tallest hill? Brian, why might they design that first hill to be the tallest one? Okay, because what would happen if the second hill was taller than the first hill? Yeah, you couldn't make it up and over, right? That'd be a really crappy roller coaster. Like you'd see this whole roller coaster thing and you'd think, that looks really sweet. And then you'd go down the first hill and you wouldn't make it up the second hill and that'd be the end of the roller coaster and you'd get off. It wouldn't work. The reason why is that first hill is the tallest is because that is where you get all your energy. All your energy is stored in you when you're up at the top. And after that, the different heights of the features that are on it get lower and lower and lower because, like Spencer said, there's friction. You lose a little bit of energy. So you've got all the energy you need there, and then after that, you kind of lose energy every place you go. So if you notice, like the big tricks typically are at the start of the roller coaster because that's when you've got the most energy, like the loops and the swirls and stuff like that. And after that, it's just like smaller hills and smaller features. but it's because energy does something. Remember back to the law of conservation of momentum that said that momentum can't be destroyed, right? But it can be transferred. Did you learn the rule about energy that's kind of the same way in middle school? Like energy. Ooh, yeah, you got a lot of it there. You missed one part of it. So energy can't be like created, and it can't be destroyed, but it can be transferred, changed, transformed. And that's what you see on a roller coaster. When you're climbing up to the tip top of the roller coaster, you've got a lot of a specific type of energy. And then as you go down the hill, you're losing a type of energy and gaining another type. Then you go up through a loop and you're losing another type of energy and gaining another type. So the reason why that works is because energy gets converted from one form into the other the whole way. You've got all the energy you need at the top of the first hill. And then after that, it just gets converted from one type into the other type, all the way through the length of the roller coaster. Stuff you might have already done before. So, like I always point out, they're your notes. So your notes need to reflect what you don't know and what you do know. So you make this look like you need to make it look to work for you. But today we're talking about energy, and specifically we're talking about potential energy. And just for the sake of the video, your essential question today is, what differences exist between the types of energy that are out there? Your code is 320. Your pages are 43 and 44 with the notes going on 44. And your topic is potential energy. So as we start off today, there's three types of energy really that we're going to focus on in this unit. So we're going to get some definitions down first. And again, if you know these already, and I suspect some of you do, then you don't need this stuff down in your notes. There is shorthand for energy if you want it. If you don't want to write energy every time, you can just use the letters like N, R, G. And when you say them really fast, it sounds like the word energy. So if you don't want to write, that's one of the shorthands you can use if you prefer. So there's two types we'll talk about here right now. One is kinetic energy. And kinetic energy, like it says, is energy in the form of motion. If something's moving, it's got kinetic energy. If something's still, it can't have kinetic energy. The other one we'll talk about is potential energy. And there's different types of it. But in general, potential energy is energy that's stored up in something. That pencil sharpener is not super deluxe. Yeah. It's the next level below functional. Would you like I've got another one, Gavin. Here you go. So kinetic energy, like it says, stuff that's moving. Potential energy, energy that's stored in something. So just relatively quickly to make sure we got it down. If I ask Chloe for an example of something with kinetic energy, she would say, yeah, an example of something that has it. Say it one more time. Two more times. A car. What would that car have to be doing? All right. What about a passenger in a car? Like someone sitting in a car that's moving. Does that person in the car that's still in the car have kinetic energy or no? Because they're kind of moving, they're kind of not moving, right? Is the person in the car moving or no?
Yeah.
So the vehicle moves, but the person stays where they are? So like when you drive to grandma's house, you hop in the car goes, but you stay right there? Right. So if the car's moving, you're moving, right? Yeah, so you've got kinetic energy too. Even if you're in like a plane or something and you're just sitting there, like you're still moving at 600 or 700 miles an hour, so you still have kinetic energy. Anything that's moving has kinetic energy. So that's one of them. The one we're going to focus on, though, is potential energy. And we're also going to go over like what the label is for it, so how you label energy, and then the third type of energy we'll talk about, which pops up on this one. So the other two vocab words you want today, the first one is joule, which is the unit for measuring energy. So just like with all the other calculations we did, in the last unit, like momentum was kilogram meters per second, all that stuff. The label for all energy is joule. You can just abbreviate it with a J. You don't have to write the word joule every time. That's the abbreviation for it. And then the very last one is mechanical energy. And mechanical energy, you can see it there. It's got the word sum, S-U-M in it. Sum is a math word. Jared, do you remember what sum means in math? Yep, that's the word we're looking for, like what it means. Nikki? Say it again. Yeah, and total means you're going to have to be doing what? Like what math action? Yeah. So when it says the sum of the potential and kinetic energy in a system, that's like you add up the potential energy, you add up the kinetic energy, and you wind up with the mechanical energy. And there's your definition right there. Energy is, right? So the definition of the word energy, all energy is the ability to do work. And we'll talk about what work is. I'll go over how the definition for that and how you do work. But today we're focused on energy. So you're just going to have to stick with me now when we talk about the word work, because we'll come back and get that in a while. But right now, energy is just the ability to do work. What's up, Shay? Yep. Seems to be. So, the two types, I'm going to have you put like a little flow chart in your notes here to talk about potential and kinetic energy, because both of them are kind of being demonstrated with this yo-yo that's right there, if you can imagine it. So you probably know the answer to this. When that yo-yo is stored like up higher in your hand, it's got a specific type of energy in it. Yeah, and even more specific than that, like a specific type of potential that maybe you know based on 8th grade. Maybe when I say it, you'll know it. If I said gravitational potential, does that ring a bell for you?
Nope.
Okay, no problem. So the flow chart we're going to start with then looks like this. You're going to build this, and you want to leave a little room because we're going to add on to it. But there is energy, which is like the overreaching category. And in energy, for us right now, it's getting divided up into two types. There's potential energy and there's kinetic energy, are the two types that it is divided up into. It's just an example, like my example of potential energy. There's a definition on there that you don't need to get down. It's a different definition for potential energy, just to help you like understand a little better. But it's got some examples, and then I'm going to ask you guys for some examples. But potential energy is energy that's stored as a result of position, like how high up something is. The higher it is, the more energy it's got in it. Or the result of its shape, like being stretched out, like if you shoot bows or something like that. When you put anybody like shoot bows in here, archery or anything. When you draw it, right, it's got a lot of energy stored inside of it, and when you let it go, it releases that energy. So there's energy stored, which is potential energy. Or when you're holding something up high and getting ready to drop it, it's got lots of energy stored inside of it. So within your groups here, and this should just take a minute or two, I just want you to come up with 3 things that have energy stored inside of them, and we'll try and break down what category they're in.